Dear children, welcome to digital lessons. In the last sessions, we have seen the chemical reactions of acids and bases and salts, and also in session 2 we have studied about the pH indicators. Now it is the session 3. Here we will deal with the chemical reactions of acids and bases and salt formation and their uses and their preparation. Do you know how these salts are produced? Yes, it is the simple chemical reaction. Whenever acid reacts with base, it leads to the formation of salt. Children, please take your notebook and pen and draw 4 columns in your notebook. In first column you put serial number, in second column you write the name of the salt, third column what is the acid used for the preparation of this salt, in fourth column what is the base used for the preparation of this salt, and finally you write its chemical composition or formula. Now you see, for example, if we take a simple salt NaCl, you know how do we prepare NaCl in our home or at laboratory? Very easy. Yes, you are right. We are mixing NaOH solution with dilute HCl solution. We are getting sodium chloride. What is the acid involved in this reaction? Yes, it is hydrochloric acid HCl. What is the base involved in this reaction? Yes, it is the NaOH solution. What is the formula of the salt formed here? Yes, NaCl. Like this, here a small exercise for you. Now I will give some chemical compounds or salts. You write their formula and also you write from which acid it is derived from, and also you write from which base it is derived from. Now you see the tabular column. First salt is potassium sulphate. Once again I will explain this for you. Potassium sulphate. What is the formula? Very simple, K2SO4. What is the acid used for its preparation? Yes, sulphate means sulfuric acid involved in this reaction. Sulfuric acid formula H2SO4. Now what is the base involved in this reaction? Yes, it is potassium hydroxide, S KOH. Now you write KOH plus H2SO4 leads to K2SO4. Like this you have to write. Now start writing. There are 8 compounds for you now. You start writing. Second compound is sodium chloride. Already we have given examples for sodium chloride, copper sulphate, sodium nitrate, sodium carbonate and ammonium chloride. Now children, here a small exercise for you. Now let us start writing the chemical composition involved in this reaction. Now here there is an acid reacting with a base to form a salt. Now what salt we have taken first? We have taken potassium sulphate. Here potassium hydroxide and sulfuric acid are involved in the chemical reaction, which is leading to the formation of K2SO4. Now you take another example, sodium sulphate. How sodium sulphate is formed? You write the base for it, you write the acid for it and also its formula. Next, calcium sulphate. How it is formed? Write base, acid. Like this you mention its formula also. Magnesium sulphate. What acid involved in this reaction? What is the base involved in this reaction? Next, very simple salt, copper sulphate. Which acid is involved? Which base is involved in this reaction? Sodium chloride, sodium nitrate, sodium carbonate and ammonium chloride. Now after writing this you check once again. Now let us examine what acid involved in this reaction, what is the base involved in this reaction. Now let us see. Now you have written I think correct formulas only, just cross check along with this slide. Now you see the chemical reaction, there also you can see formula for the salts. Now you see the first one, you have written potassium sulphate, K2SO4 is the formula. What is the acid involved here? Sulfuric acid H2SO4. What is the base involved here? KOH solution. Next, sodium sulphate. What is the acid involved here? H2SO4. Now, you can notice that here all acid involved is H2SO4 only for all these chemicals. First, along with the reaction of NaOH, we are getting sodium sulphate. Its formula is Na2SO4. Next, sulfuric acid is reacting with calcium hydroxide. It is giving rise to a salt CaSO4. Next, magnesium hydroxide is reacting with H2SO4. It is giving rise to magnesium sulphate. Please remember children, here all salts are formed along with the formation of water molecule. Next, you check another slide. Now, copper sulphate, it is derived from H2SO4 and copper hydroxide. Now, next sodium chloride, we are changing the acid. NaOH is reacting with hydrochloric acid to form NaCl. Now, next we are changing another acid. NaOH is reacting with nitric acid to form sodium nitrate. NaNO3 is its formula. Now, NaOH is once again reacting with carbonic acid H2CO3. Therefore, here the salt formed is sodium carbonate. Yes children, it is right, it is nothing but washing soda. After some time, we will see the difference between washing soda and our formula. Next, whenever ammonium hydroxide is reacted with hydrochloric acid, we are getting a salt called ammonium chloride. Its formula is NH4Cl along with the formation of water molecules. Now, what is happening in these chemical reactions? According to this chemical reaction, we can divide the salts into their families. Now, there are two types of salts primarily. They are salts based on positive ion, that is cation, salts based on negative ion, that is anion. Look here children, for example, salts based on positive ion means, for example, if we are having a salt NaCl, it means whenever we dissolve it NaCl in water, it dissociates into its ions. First ion is Na plus ion. What is this ion? It is a positive ion. It is also called cation. What is the another ion? Cl minus. It is anion. It is having negative sign. Now, take another salt, sodium sulphate. What is the cation formed here? It forms Na plus 2 ions. That means it is a cation. You take another anion here, which is formed, it is sulphate ion, SO4 minus 2 ion. Now, look here children, which is common here in both these salts? Sodium ion is common, Na plus ion, Na plus 2 ion. It is a cation. Therefore, it is called sodium salt or otherwise cationic salt. Next category is salts based on negative ion, that is anion. We know whenever NaCl dissociates into water, it forms Na plus ions and Cl minus ion. What is cation here? Yes, it is sodium. What is anion here? Yes, it is chloride ion. Next, if we take KCl, it dissociates into water to form potassium ions and chloride ions. What is cation here? Yes, it is potassium. What is anion here? Chloride ion. What is common ion here? Yes, it is chloride ion. Therefore, this salt is called categorized as chloride salt or anionic salt. Now, like this we categorize the salts into their family. It is the many types of salts are there. We are based, fundamental quality is based on its anion and cation. Based on these type of salts we name them. Next, now here just a small repetition. We are getting two salts here. In the first case we have seen NaCl and Na2SO4, sodium sulphate and sodium chloride. Here which is common? Cation is common, therefore it is named as sodium salt. Next type of salt, if we take, there we are seeing sodium chloride and potassium chloride. Which anion is common here? Chloride ion. Therefore, it is named as a chloride salt. Now, from our laboratory, collect the samples like sodium chloride, sodium acetate, ammonium chloride, and take these salts and dissolve them in distilled water. Now, whenever you dissolve them in salts in distilled water, it bifurcates it into ions, it dissociates into ions. What are the ions formed here? Sodium chloride, sodium ions and chloride ions. What are the sodium acetate ions formed with sodium acetate? Sodium ions and acetate ions. What is the ions formed with ammonium chloride? Ammonium ions and chloride ions. Now, let us check whether the salts formed with this category, whether we are getting the salts of acidic salts or basic salts. Now, let us check the pH value of these solutions with the help of a pH paper. Now, after this we have to fill up this tabular column. Now, take the salt NaCl, observe its pH value in pH paper. You will notice that it is absolutely 7. That means, it is neither acidic nor basic, it is a neutral salt. Next, whenever you dip a pH paper in sodium acetate solution, you will get pH value is greater than 7. That means, it is basic salt. Why it is basic? You can think very easily. Yes, ions involved in this reaction are acetate and sodium ions. Now, look at the chemicals involved in this reaction, sodium hydroxide and acetic acid. Now, which is the stronger one? Either acetic acid or sodium hydroxide? Yes, children, it is right. Sodium hydroxide is the strong base when compared to acetic acid. Acetic acid is regarded as weak acid. Therefore, what will be the salt formed of this category? Yes, here sodium hydroxide is stronger. Therefore, base is stronger. It is basic salt. Next, whenever you dip pH paper in NH4Cl, now here you will get the pH value less than 7. That means, it is acidic solution. Now, what are the acids and bases involved in this reaction? Just think, children, ammonium chloride is the salt. What are the bases and acids? Acid is dilute hydrochloric acid, the base is ammonium hydroxide. Now, which is stronger one? Yes, it is hydrochloric acid is the stronger one when compared to NH4OH, which is a weak base. Then you can guess what will be the salt formed of this category. Here acid is stronger, therefore, you can see that it is a acidic salt. Now, here we categorized 3 salts, ammonium chloride and also sodium acetate, and also one is stronger acid, we are getting acidic salt. If base involved is stronger base, we are getting basic salt. Both are strong bases and strong acid, or weak acid, weak bases. Here we will get the salt of neutral in nature, where pH value you will found absolutely 7. Now, next, children. Now, small recapitulation of this one. Salts of strong acid and strong base are neutral and pH value is 7, already we have seen, and salts of weak acid and weak base also give us neutral and pH value will be 7. Next, salts of strong acid and weak base are acidic, whose pH value is less than 7. Salts of strong base and weak acid are basic in nature and pH value is more than 7. Now, look at our common salt. Now, what is the formula of common salt? It is NaCl. Now, you can observe here lot of varieties of common salt. Normally, the white color one which you are seeing in middle, it is rock salt. Normally, we will use at our homes. Did you observe this black color salt? It is a rock salt. It is mined from the earth crust. There are other categories of salts also. Here you can observe lemon salt, which you observe during the preparation of pulihora at your houses and festival times. Now, these are the types of salt. Now, why this salt is very, very important, children? Yes, it is very, very important salt, because it is used as a raw material for the preparation of various salts such as sodium hydroxide and also bleaching powder, baking soda, washing soda, can also be prepared by this salt. Do you know? Yes, how it is prepared from NaCl. Now, let us see what is the experiment involved. How do we convert NaCl into NaOH? There is a process called chloro-alkali process. Here we will pass chlorine gas through NaCl solution. Generally, NaCl solution is called as brine solution. Now, let us see children. Now, common salt, a raw material for various chemicals, sodium hydroxide, baking soda, washing soda, bleaching powder can also prepared with the help of common salt. Now, what is chloro-alkali process? Now, in this process electricity is passed through the brine solution. Already we discussed what is brine solution. It is nothing but a solution of dissolved our common salt, that is nothing but sodium chloride. Whenever electricity passed through it, it decomposes to form sodium hydroxide. In this chloro-alkali process, the solution of NaCl dissolved in water, whenever electricity is passed through this solution, there will be anode and cathode in this reaction. Now, you will see what happens in this reaction. Now, let us see. Now, here NaCl is dissociated into its ions. What are the ions formed? Na plus ions and Cl minus ions. What is cation here? Yes, Na plus ion. Being cation is attracted towards cathode. And what is the anion here? Chloride ion. It is attracted towards anode in the form of two chloride ions deposit together to form a chlorine gas. It exactly happens in the reaction. Now, we will see what happens detailedly. Children, you have seen this video. What is happen in this video? Whenever electricity is passed through the solution, now cation is attracted towards cathode, anion is attracted towards anode. Now, you see the diagram which is given in our textbook. Now, you see here there is an aqueous NaOH solution, that is nothing but brine solution. Now, what is anode here? Anode is a positive terminal. What is cathode? Cathode is a negative terminal. Whenever NaCl dissociates, it forms Na plus ions. It is a cation. Therefore, it is attracted towards cathode and we are getting the formation of Na. Now, aqueous solution. Here water molecule is also involved in the reaction. Now, water bifurcates into hydrogen ions and also H plus ions and also OH minus ions. Now, you see, now this Na plus ions attach with the OH minus ions, which leads to the formation of sodium hydroxide near cathode and chlorine, chloride ion being anion, it is attracted towards anode which is a positive terminal. Remember children, anion is having negative sign Cl minus, anode is having positive terminal. Therefore, now Cl minus ions rush towards the anode and liberated in the form of chlorine gas. Now, this is nothing but chloro-alkali process. Why? Because here chlorine gas is evolving out. Therefore, the name chloro is given. An alkali is produced. What is an alkali? It is nothing but a base, that is sodium hydroxide. Therefore, this process is called chloro-alkali process. Now, we will see the chemical reaction for this chloro-alkali process. Now, what happens? Whenever NaCl molecule dissociates in water, when electricity is passed through it, it forms sodium hydroxide and chlorine gas as well as hydrogen gas. Next, we can see here in the form of a small diagram which is given in our book. Now, a salt is dissolved in water and electricity is passed through it. What we are getting at cathode? We are getting at cathode hydrogen gas. What we are getting at anode? We are getting chlorine gas as well as sodium hydroxide solution. Where do we use this hydrogen gas? This hydrogen gas we will use as fertilizers and also chlorine gas is used as a treatment for water by our municipality people, and also whenever we mix this hydrogen and chlorine, we will get hydrochloric acid also. Now, sodium hydroxide solution, it is also used in paper industry and also preparing artificial fibers. Now, it is also used as a good bleaching agent. Now, bleaching agent means chlorine is the having the bleaching property, it is used as a bleaching powder to make bleaching powder also. Now, let us see how do we make bleaching powder in our lab. Now, bleaching powder, have you seen bleaching powder? Yes, bleaching powder is a good cleaning agent, it kills microorganisms. How this bleaching powder is prepared in our lab? Bleaching powder is produced by the action of chlorine on dry slaked lime. Dry slaked lime means it is nothing but lime water, crystals of lime. Here we won't find any water, small droplets of water we will find. Now, bleaching powder is represented by the formula CaOCl2. What does it mean? CaOCl2 is nothing but calcium oxychloride. Now, let us see children how this bleaching powder is prepared industrially. Now, children, we will see how bleaching powder is prepared industrially. We can prepare bleaching powder very easily. Now, you can look at the setup here in this video. There is a cylinder in which we are taking dry slaked lime. It is nothing but calcium hydroxide. In the upper chamber, it is dry slaked lime is rotating and it is going downwards. Now, there is an inlet here. Through this inlet, hot chlorine gas is being pumped into the mixture. Now, what happens here? Calcium hydroxide react with chlorine gas. It forms CaOCl2, which is our bleaching powder. Now, look at the reaction. While rotating fastly, reaction will occur very fast, but always it will go very slowly. We will get finer composition of bleaching powder particles whenever reaction is very slow. Here you can observe calcium hydroxide molecules are reacting with chlorine and forming bleaching powder CaOCl2, and here hot air is being pumped from the bottom of the chamber. Now, this hot air removes the water formed in the reaction. We will get dry bleaching powder in the form of small crystals at the bottom of the chamber. Now, we can collect this from the bottom. Unused chlorine gas escapes into the atmosphere and also water goes out in the form of water vapor. It is the procedure how industrially we can prepare bleaching powder. Now, let us see what are the uses of bleaching powder. The name itself indicates it bleaches. Bleaches means it is used as a decolorizing agent. Normally, this will be used as in sugar industries also. It removes color of sugar crystals, and also it is used in paper industry also. Here it removes the wood pulp color to the paper and we will get a fine color of paper, that is white in color, and it is used as a bleaching agent in textile industry. It is used as an oxidizing agent for many chemical industries. Now, oxidizing agent, now the formula itself indicates what is the formula of bleaching powder? CaOCl2. Here we can get very active oxygen, that is nascent oxygen. It is used for killing microorganisms in our water. Therefore, we will drink microorganisms free water, cleaning our surroundings with the help of bleaching powder, thereby killing microorganisms in the area. Now, next important chemical salt is baking soda. Now, you might have observed, where do we use baking soda? Your mouth be watering. Why? As you are getting the assumption of mirchi and samosa or bonda, which is prepared at your home. Now, you see picture here. Why these are bulged in size? Because they are mixed with baking powder. In preparation of cakes also we use baking soda. What is the chemical name of baking soda? Yes, it is sodium bicarbonate or sodium hydrogen carbonate. It is represented with the formula NaHCO3. Now, How baking soda is prepared industrially? It is prepared from sodium chloride. We will take aqueous sodium chloride and pass carbon dioxide gas and ammonia through it. We will get the crystals of sodium hydrogen carbonate along with the ammonium chloride. In this way, we can prepare baking soda commercially. Now, what are the uses of this baking soda? Normally, people will think that baking soda contains only sodium bicarbonate, that is sodium hydrogen carbonate, but it is also along with some other components. It is nothing but calcium phosphate and starch. In this way, you can observe the difference between baking powder and baking soda. Baking powder normally used in the preparation of cakes and baking soda used in the preparation of bonda and mirchis. Now, sodium hydrogen carbonate we will used as a best ingredient for a person suffering acidity. If we take dissolved baking soda, it removes acidity, we will get immediate temporary relief. It is also used as a fire extinguisher, that means it is to stop fire. It is used as a mild antiseptic. Whenever some itching sensation is there on our skin, we can apply baking soda and we can get relief. Now, another important salt prepared from common salt is sodium carbonate. Do you know how sodium carbonate is prepared in the laboratory? If we take two molecules of NaOHCO3 and heat it, we will get sodium carbonate. Now, it is a small reaction. Whenever we heat baking soda in the laboratory, we will get sodium carbonate along with the formation of water and carbon dioxide gas. Both in the form of vapor, they will lose into the atmosphere and we will get only sodium carbonate. After heating sodium bicarbonate, we will get normally small crystals. Again, we have to dissolve those crystals in water and heat it. We need to add more and more sodium carbonate, so that it will be dissolved completely. After cooling, we will get fine crystals of sodium carbonate. It is called recrystallization. Now, once again remember children, what we are doing in recrystallization? We are dissolving the sodium carbonate and we are waiting for some time, 10 minutes or half an hour. In that time, we will get the formation of the crystals of washing soda. In washing soda, we observed there are 10 water molecules, Na2CO3, 10 H2O. That means, where do these 10 water molecules are coming from? Now, just take small amount of sodium carbonate in your hand and just rub it like this. You will have a sensation soapy touch. That means, it is having some water molecules. Whenever we heat it, corners of the test tube, we will observe small droplets of water. Now, let us see, there is another compound like this, copper sulphate. Do you know the color of copper sulphate, children? Yes, it is sky blue like our background slide. 5 water molecules are associated with it. Now, let us perform a small experiment for this. Let us see, children. Now, you observe here, I am taking copper sulphate in a test tube. Now, I am heating it. Now, you take care that it should be above the blue flame, because heat will be supplied more. Now, you see small droplets of water are evolving out of the test tube. Now, you can also notice the color change. Some copper sulphate is losing its color. You can see vapors of water also from the test tube. And now, you observe carefully, there are some water droplets on my test tube. Color of copper sulphate is lost. Copper sulphate is turned into anhydrous. It is losing its color slowly. Now, whole process is completed. Copper sulphate is turned into anhydrous copper sulphate. Now, at this time, you wait for 10 minutes. Do not add water immediately, because already our test tube is overheated. When you add water, it breaks up. Now, here I am adding water to my anhydrous copper sulphate. Now, you see, on adding water, slowly the color is changed to sky blue color. It is the copper sulphate color, which is associated with 5 molecules of water. Therefore, in this reaction whenever we are heating, it is losing some water molecule, it is nothing but water of crystallization. Copper sulphate which is associated with water molecules is having blue color, copper sulphate which is lost its water molecule is colorless. Again if we add water, it turns back and we will get blue color of the copper sulphate. Next, another important salt which can be prepared from sodium chloride is plaster of Paris. Now, what is plaster of Paris? Normally we will use for decorative articles and toys at our home, and also here you can see the picture, he is putting a plaster of Paris bandage there. Now, this means it is hard. Now, here it is the powder of plaster of Paris. Whenever it is added to water, it forms gypsum, it is a hard solid mass. Therefore, we cannot bend our hand, so that our bones will set right. Plaster of Paris. How do we prepare this plaster of Paris in our lab? By taking a reagent called gypsum. Its formula is copper sulphate 2H2O, CaSO4 2H2O. Here I am taking the temperature in Kelvin, 373 Kelvin, that means it is 100 degrees centigrade. Now, it loses its water molecules, 1.5 water molecule is lost, we are getting only half water molecule. This means here copper sulphate is called as a copper sulphate hemihydrate. This is nothing but plaster of Paris. Now, whenever this plaster of Paris is added to water, it again forms gypsum, it is a hard solid. What we have learnt in our session so far? We learnt about the important salt, that is sodium chloride, how it is formed, from which acids, from which bases, and writing their correct chemical formula, and also what are the other salts derived from sodium chloride, washing soda, bleaching powder, baking soda and plaster of Paris, all these are prepared from our common salt only, and also we studied about plaster of Paris and also water of crystallization. Dear children, let us meet in the next class to have another wonderful session. Thank you children.